The science behind weather prediction. At its core, weather prediction is based on the study of atmospheric patterns and how they change over time. The Earth's atmosphere is a dynamic system influenced by air pressure, temperature, wind currents, and moisture levels. Meteorologists analyze these factors to determine how they interact and evolve. One of the most important concepts in weather prediction is atmospheric pressure. Areas of high pressure usually bring clear skies, while low-pressure systems are associated with storms and unstable weather. Additionally, global patterns like the jet stream, ocean currents, such as El Niño and La Niña, and seasonal shifts play a major role in determining weather conditions worldwide. By studying past weather trends and using real-time data, meteorologists can anticipate storms, heat waves, and temperature fluctuations, allowing them to create more accurate forecasts. How meteorologists collect weather data. To make accurate weather predictions, meteorologists rely on a variety of instruments and data sources to measure atmospheric conditions. Some of the most important tools include satellites. These provide a global view of cloud formations, storm systems, and temperature changes from space. Weather balloons, released twice a day. These balloons carry instruments that measure temperature, humidity, and atmospheric pressure at different altitudes. Radar systems, used to track precipitation, thunderstorms, and hurricanes in real time. Doppler radar helps detect wind speed and rotation, which is crucial for predicting tornadoes and severe storms. Ground-based sensors, located at weather stations worldwide, these devices measure temperature, air pressure, wind speed, and humidity to provide localized weather data. By analyzing this collected data, meteorologists can determine how weather conditions are developing and predict their future impact. The role of supercomputers and weather models. Once meteorologists collect data, they input it into advanced computer models that analyze trends and generate forecasts. These models are powered by supercomputers, which process vast amounts of information at incredible speeds. There are two main types of weather models. Global models. These predict large-scale weather patterns over an extended period, exemplification the Global Forecast System, GFS, and the European Centre for Medium-Range Weather Forecasts, ECMWF. Regional models. These focus on more detailed, short-term forecasts for specific areas, e.g., the North American Mesoscale (NAM) model. Meteorologists compare multiple models to improve accuracy, since weather is a constantly changing system. The combination of real-time data, historical trends, and advanced computing helps create reliable forecasts, but no prediction is 100% accurate due to the complexity of atmospheric conditions. The challenges of predicting the weather. Despite the advances in technology, weather forecasting isn't perfect. One of the biggest challenges is the chaotic nature of the atmosphere. Small changes in one part of the world can have unexpected effects elsewhere. This concept is known as the butterfly effect, where even tiny shifts in temperature or wind direction can significantly alter weather patterns. Another challenge is long-term forecasting. While short-term forecasts, 1 to 3 days, are generally highly accurate. Predictions beyond a week become less reliable. This is because numerous variables influence the weather, making it difficult to predict conditions with complete certainty. Additionally, severe weather events such as hurricanes, tornadoes, and snowstorms can change course unexpectedly, requiring meteorologists to constantly update forecasts based on new data. Even with these challenges, continuous improvements in technology, AI, and climate modeling are helping meteorologists refine their predictions and better prepare communities for extreme weather. Fun facts about meteorology. The first weather forecast was published in a newspaper in 1861 by British meteorologist Robert Fitzroy. Lightning is hotter than the surface of the sun, reaching temperatures of 30,000 degrees Celsius (54,000 degrees Fahrenheit). The world's hottest recorded temperature was 56.7 degrees Celsius (134 degrees Fahrenheit) in Death Valley, California, in 1913. The wettest place on Earth is Mawsynram, India, which receives an average of 467 inches (11,871 millimeters) of rainfall per year. Red skies at sunrise or sunset can indicate approaching storms. This is where the saying "red sky at night, sailor's delight, red sky in morning, sailor's warning" comes from.